Don't you think we're done? Don't you think we're done? Don't you think we're done? Knew that it was true from the way you looked at me. I'll be your anything if you'll be the one to take me home. Makes me wanna leave this place and roam. Make me feel alive. Take my hand and run, let me be the one. Let's just take the dive. Night's only begun, don't you think we're done? Don't you think we're done?
In this lecture, we are going through inner classes in Java. So I am in Eclipse as usual, and I have a basic class that has a main method. I'm gonna create a new class here, and we're gonna give this new class some inner classes. I'm gonna right-click my package here and go to New Class. I'll call this class Machine just to have an example to work with. I'll click Finish. I'm gonna give Machine some instance data. I'm gonna give it a private int ID. So in this case, every machine has an ID, and I'm also gonna implement a constructor so that we can set the ID. To do that, I'm gonna right-click and go to Source, Generate Constructor using Fields. Tick ID and click OK. I'll delete the super here, cause that's not needed. So the constructor just takes an ID and sets this private field using the ID passed in. Let's give this one more method. Let's give it a public void run method. And in run, I'll just put a sysout statement and I'll say run machine plus ID. So now I can use that by going to my main method here and creating a machine, set that equal to a new machine. I'll pass the ID 12. And then say machine.run, like that. So that's all pretty straightforward. We're running machine 12. Now let's take a look at inner classes. In previous lectures, we've already looked at anonymous classes, and anonymous classes are a kind of inner classes. We are going to explore at 3 other inner class types here in this lecture. So in Java, you can declare classes pretty anywhere. And you've seen in previous lectures that you could declare a class up here or down here. The only rule is that you can only have one public class in each file, and its name is going to match the name of the file. So this is machine in machine.java, but I can create a class within the machine class. Let's first take a look at non-static inner classes. They are also called nested classes. So I can declare a class here. Let's call this class Artificial Intelligence, like this. And this class will now have access to the instance data of the machine class. I'll also give this class a method, public void activate. We could have a sysout here. Let's say machine plus ID plus is activated. I could give this class instance data itself, but the point here is that I am accessing instance data of the machine class within this inner class. And then in the run method of machine, I could say, for example, artificial intelligence, AI, equals new artificial intelligence. And it says machine 12 is activated. So this is an inner class or a nested class. And classes like this are most often used for logically grouping different parts of outer classes. For example, machine might have actions, data, memory, etc. And you can group different parts of the machine by using inner classes. Now another type of inner classes are static inner classes, which are pretty simple. So I'll say here, for example, let's say static class tire. Add brackets in. And we could also have a method. Let's say public void repair. Let's just put a sysout in here and just say tires are repaired. Now, because this is static, we can't refer to this ID. I cannot say plus ID here. That would give me an error unless I declare ID static, because a static inner class can access static variables of the outer class. But what you usually use static inner classes for is to just group classes together. So let's say in this case you've got machines and they can have interchangeable tires. So you might want to create machine tires outside of this class, and then pass it to whatever machine need those repaired tires. So we could say here, outside of the machine class, we could say machine.tire tire equals new machine.tire. And then we can say tire.repair. Let's run this, and it says tires are repaired. So non-static inner classes are used when you need to group together some functionality, and you need the class to have access to the instance variables of the outer class. On the other hand, static inner classes are used when you just want a normal class that isn't related with instances of the outer class, but for some reason you want to group it with the outer class. And other than that, it's really just a normal class. So the static inner classes are like normal classes that just happen to be grouped with other classes, and you use this kind of dot syntax. Now there is another thing I'd like to mention here, and that is that you can declare classes even within methods. I can say here, class test. And this would have access to ID. So let's give it a method. Public void, let's say example. And I can say here, sysout ID is plus ID. It would also have access to stuff we declare in here. So if I say final string, type equals electric, we could say here, sysout type is plus type. And this follows the same rules as anonymous classes, that if you have a method, it can only refer to local data if it's final, but it can refer to instance data absolutely fine. We can also create an instance of this class saying test equals new test, and then we can say test.example. So when we run this method, you first run all of this. So I'll run this and there we go. You can see type is electric and all this stuff. So again, this is sometimes useful. It is not very common, but can be used if you need an instance of a class to pass to another method. And for some reason, you don't want to use an anonymous class. You just want a class that you only want to use in this method. You can create an instance of it only in this method, because you can't refer to this class now outside this method. You can't make it private, public, or protect it in any way either, because its scope, along with the scope of these variables of course, is between these brackets here. It's scoped to this method. And that's how we came to the end of the inner classes in Java. If all of this seems as a lot of information at once, please find this code at the resources section and practice with it. I'd recommend typing out some code and trying to think of some scenarios yourself for each different type of inner classes that we have gone through in this lecture, and you'll soon get it. So that's it for this time, and until next time, keep practicing.